Good morning, students. Today we shall look at the topic probability. Before we go to the mathematical notion of probability, let me explain probability on the following pages: the origin, the meaning, origin, and application. What is probability? Probability is the study of unpredictable events. Events that you are not certain or sure about. Okay? Probability originated in the mid 17th century. Mid 17th century. How? It was inspired by the inquiry of gamblers seeking information on how to win games on cards and cards and dice. Die is singular, dice is plural. Okay? Now, application. Probability has many important commercial and scientific applications. One of them is in life assurance companies or in insurance matters. How? They use tables. These companies use tables to help them calculate the tables of life expectancy. Tables of life expectancy in order to help them calculate their premiums. Okay? Premiums. The second one, applications of probability, is in industrial quality control. Industrial quality control. Very soon we shall take an example on this, industrial quality control, as well as efficient use of resources. Efficient use of resources. Okay, so now let's go to the mathematical aspect. Now, before we define the mathematical notion of probability, let us look at some basic terms. Basic terms or language of probability. The basic terms or language of probability. The first is, very quickly, experiment. What do we mean by experiment in probability? It is any process that produces an outcome. Any process that produces an outcome. An example of experiments in probability is tossing a coin or flipping a coin. Tossing a coin or flipping a coin. Another example of experiment in probability is rolling a die. Rolling a die or throwing a die. Okay? So these are two examples of experiment in probability. The second one is outcome. What is an outcome in probability? An outcome is simply the result. Outcome is the possible result of an experiment. The possible result can be 1 result of an experiment. Okay, the possible result of an experiment. The third one, let's look at event. Event. What do you mean by an event in probability? Okay, an event is simply, or before event, let's look at sample space. That will be better. Sample space. Okay, sample space is the set of all the possible outcomes of an experiment. Look at this table. You have the experiment tossing a coin or throwing a coin. The possible outcomes are, you can either have a head or a tail. Rolling a die or throwing a die. I said tossing a coin or flipping a coin. It's either you have the head or the tail. Then rolling a die or throwing a die. It's either you have 1, 2, 3, 4, 5, 6. In other words, the face of the die can show any of this number. You can see the two dice on the board. Can either show 1, 2, 3, 4, 5, or 6. Okay, so these are the possible outcomes. So if you now put the possible outcomes as a set or as a group, that is the group or the set of the possible outcomes, is what is referred to as the sample space, denoted heads. So for the experiment tossing the coin, the sample space, in other words, the sample space is a collection. You remember the topic said, a collection of all the possible outcomes of an experiment. So head, tail, just two. So the symbol or letter S is used to denote the sample space. Then this denotes the number of outcomes in the sample space. You remember your cardinality of set, the number of elements in the set. So the number of outcomes in this sample space, just two, head or tail. So two. There are two outcomes in this sample space. The other one, the sample space for rolling a die, that's a collection of all the possible outcomes. You have 1, 2, 3, 4, 5, and 6. So the number of outcomes in the sample space for the experiment rolling a die, number of x is equals to 6. Is that again? Okay, now the last one, the fourth one, sorry, not the last, event. Event is represented with the letter E. Okay? An event in probability simply means a part of the sample space, is a subset of the sample space. Okay? For example, if we are interested in the event even numbers, okay, from the rolling of a die, even numbers, I can represent that the event, even numbers, represent that with E1. So the even numbers in the sample space for the experiment rolling a die, we have 2, 4, and 6. Okay, we may also be interested in the event, let's say, perfect squares. Let me represent that with E2. Event E2. So the perfect squares in the sample space are 1 and 4. So in other words, an event is simply a part of the sample space, just the subset of the sample space. 2, 4, and 6 belongs to the sample space. They are elements of the sample space. 1 and 4, they are elements inside the sample space. Okay? Now, let's look at a close term that is closely related to this. Complementary events. Complementary events. Complementary events. Complementary events. Complementary events are complementary sets. Okay? Complementary sets such that the sample space serves as the universal set. Okay? So for example, the example we see on the board, even the event, even numbers. Event, even numbers. We have E1, 2, 4, 6. Okay? So the complementary event to this will be those elements that are not in E1 but in the sample space. Okay, so I can call this, let me just use E here. So E complement will be 1, 3, and 5. Okay, so complementary events are complementary sets such that the universal set, the sample space, serves as a universal set. You are familiar with set, the term is set. Complementary set to this are elements that are not in this set E, but are found in the universal set. In this case, the sample space. Okay, let's look at the last one very quickly. The last one is randomness and equally likely. The fifth one, equally likely outcomes or randomness. Okay. Now, if we have 4 balls, 4 identical balls, okay, the same size, let's say yellow, red, blue, and green. All the 4 balls, they are identical in size, okay, yellow, red, blue, and green balls. They are inside a bag. What does it mean to pick a ball at random? What does it mean to pick a ball at random? It simply means that each ball is equally likely to be picked. Each ball has equal chance of being picked, meaning that we cannot predict the color of ball that we are going to pick. That is this particular color that we are going to pick. Each ball has an equal chance of being picked. So that is the meaning of equally likely outcomes or randomness. Okay, so let's quickly go to the mathematical notation of probability before we take some examples. Mathematical notation of probability. Definition. We want to define probability mathematically. Okay? Before we do that, let's go back to some of the basic terms that I've explained. The first one is sample space. The sample space. Okay? Now, in this case, the sample space, S, the letter S, represents sample space. For the course of our work, our sample space will be a finite set. A finite set means that we can list all the outcomes of the sample sample space, or we can count all the outcomes of the sample space. So E, let E represent an event in the sample space. Okay, an event in the sample space in which the outcomes are equally likely. Okay, so these two conditions are very important. S is a finite sample space, and E is an event in the sample space in which the outcomes are equally likely. So how do we now define the probability of an event E? So the probability of an event E is the number of outcomes in the event E over the number of possible, or like total outcomes in the sample space, like I've done at the beginning. So this is the number of outcomes in the event E over the number of outcomes in the sample space. So this is the mathematical definition of probability. Number of outcomes in the event over number of possible number of outcomes in the sample space. You can say the total number of possible outcomes. Okay, so how do we represent probabilities? Probabilities can be given. So in other words, the definition on the board, probability is a ratio. It's a ratio. Number of outcomes in event E, number of outcomes in the sample space S. It's a ratio. Probability can be given as a fraction. It can be given as a percentage, and it can as well be given as a decimal fraction. A decimal fraction. Don't forget from elementary classes, fractions, percentages, and decimal, they are equivalent expressions. They mean the same thing. It's like saying a cup is half full, or half empty. Half full, they are saying the same thing. So whether a fraction or a percentage or a decimal fraction, they are equivalent expressions. They are the same. For example, 1 over 2 is the same thing as 0.5, the same thing as 50%. Okay, you are saying the same thing using 3 different ways or means of expressing yourself. But it is common. Fraction is the most common way of expressing, writing, or computing in probability. But in case you are giving percentage, you know how to convert a percentage to fraction. Or if you are giving a decimal fraction, you know how to maybe 0.75. 0.75 is 3 over 4. Okay? 3 over 4 or 75%. You know how to do that. Okay? So now let's go to another aspect. The scale or range of probability. The scale or range of probability. Okay. Probabilities are usually given in the range or scale of 0 to 1. Okay, probability of an event is less than or equals to 1. Okay, so in other words, we can have something like this. If I tell this is 1, this is 0. Okay, in other words, the probability can be 0, it can be 1, but it cannot be less than 0, and it cannot be higher than 1. So probability of an event is given in this way. You all are familiar with range of values. Range of values in inequalities. Range of values. So if you have this scale, so an event, I want to combine this with types of event. An event that has a probability of 1 simply means that it is certain, we are 100% sure that that event will happen. So that is a certain event. Okay? An event that has a probability that is close to 1, close to 1 is a likely event. Okay, close to 1, maybe something like 0.9, 0.87, and so on. Okay, an event that has a probability of 0.5, 0.5 is same thing as half, is an even chance event. Okay, like in a football match, maybe between Chelsea and Liverpool, it's 50-50. It's equal chance. So an even chance event. An event that has a probability of 0 is an impossible event. Okay, for example, in my explanation on sample space on a die 1, 0, 1, 2, 3, 4, 5, 6. If I ask you to find the probability of obtaining a 7 from throwing a die, it's not possible. So the probability is 0, so an impossible. An event that has the probability close to 0, is an unlikely event. Okay, so let's quickly, before we take examples, let's look at one more thing before we take examples. Very quickly, we are lucky that we have looked at complementary event. So the probability of the sum of the probability of an event and the complementary event is 1, sorry. Let's write this probability of an event, probability of the complement. This probability of an event, probability of the complement of this event, denoted P prime, complement. So probability of plus probability of the complement is 1. Or you can interpret it this way, that the probability of an event happening plus the probability of that same event, the probability that that same event will not happen is equal to 1. Probability that an event will occur or will happen plus the probability that that same event will not happen is equal to 1. Okay, so now the last one, let's look at another concept of probability, expectation. Okay, the expectation of an event is defined as the number, defined as the product, position of an event A is defined as is equals to n times probability of A. Okay? reliability of that event in any single trial. So that is the expectation E of an event. So in the next class, we will look at some examples. Thank you.